So agentic infrastructure offers really unparalleled ability to engage users on an individual level. That's because you assign one agent to each individual user. So that agent is that user's personal concierge, sits there and tries to figure out how to make that user happy. Now, that works really well as long as that user is feeding information to the agent. If the user is doing things, and the agent can look at that and make decisions about proper next steps. However, in a lot of cases, the problem is that the user isn't doing anything. No matter what the agent tries, the user doesn't respond to anything. In that case, all the agent can do is randomly select options and hope that it hits something. It's not a very efficient way to search through the options. A more efficient way to address that would be to just pick the most popular options among the entire user base and hope that works. That's basically an A/B testing kind of approach. The problem there is that you're catering to your largest minority. And no matter how many options you have, picking one of them just because it's most popular, I mean, it's most popular among perhaps a substantial minority, but it is still just a minority. When in fact, interests and preferences tend to run in niches. An even more efficient way of searching options would be to leverage information about what niches exist. So you identify what niche a user is in and then pull the preferences of users who are similar. The way you can do this is through an embedding space. Now, embedding spaces have been used in lots of different things. They're the basis of generative AI products like LLMs, in that you take a whole bunch of sequence information. In the case of an LLM, it would be a sentence, or you encode it into a numerical representation of different tokens. We can do a similar thing with behavioral embeddings. We can take all of the different events that a user can trigger on an app, and we can summarize that information and then use that multidimensional space to do a nearest neighbor search. So I've taken one embedding space from one of our customers. This is a 7-day embedding space, so it's recent behavior. I've performed some multidimensional scaling to get it presentable on a 2D surface. In fact, this embedding space has around 70 different features. No human can visualize a 70-dimensional space, especially not on a 2D screen. So I've used some statistics to reduce it to this 2D representation, but you can still get an intuition of what's going on. Each of these dots is a user, and their proximity is based on which events they tend to enact during that 7-day period. Now, if we go and we look for order complete, you can see users over on the right were more likely to be doing order completed. That's what the darker shade means, is they were doing more of that. You can see there are still some in other places, but you see a lot more of those users over on the right-hand side of the graph. Whereas if we looked at something like add to cart, you can see it's mostly up top. So those users who are on the top left quadrant of the graph are your cart abandoners. They're the ones who tended to add to cart but not complete an order. Whereas those on the right-hand side were the ones who added to cart and did complete an order. Now, what about that bottom part? Why did they suddenly disappear? They ordered, but it's not showing add to cart. Well, this particular app actually instruments two different add to cart events. The one that's called add to cart is in fact adding to cart for food delivery. The other add to cart is for their grocery delivery business. And if we switch to that, there's your other half. So left-hand side tends to be add to cart. Right-hand side tends to be purchases. Top side tends to be restaurant business, and bottom side tends to be the grocery business. Now, is that the main features of that embedding space? Not necessarily. First of all, you can notice there's a lot of noise. There are still people with fairly dark shadings up in the top quadrant. The statistical tool I used to reduce this to a two-dimensional space picked those as some of the most salient features. The beauty of an embedding space is that you don't have to decide to just look at different similarities. It's not a simple segmentation. Instead, we go back to everyone, and if you pick a user, that agent wants more ideas of how to contact that user, it's going to look at these users right here, the ones right in closest proximity. By doing that, you get the benefit of figuring out what is popular among other people, but you get the precise targeting of finding out what's popular within the specific niche to which your user belongs. And you can do that for every single user, thereby generating new ideas. This is a way that agents are able to converse with one another. They're able to share notes in order to get the best solution as fast as they can.